This next problem is number 9 in the lecture examples, and it asks how many moles, so that's what we're looking for, moles, are present if you have 2.00 times 10 to the 22nd atoms of sulfur. So we're going from atoms to moles. So that means we're going to have moles on top. It's 1 mole because it's always 1 mole. And 1 mole is, I know, to be 6.02 times 10 to the 23rd. Since we're talking about an element, it is atoms. Atoms will divide away and we'll be left with moles. So that's going to be 2 divided by 6 is like 1/3, and then 10 to the 22nd divided by 10 to the 23rd. So that's going to be 1/10 of 1/3. So we're talking, what, 3%, so 0.03-ish. So put it in the old calculator. And it comes out to be, now the calculator reports it as 0.03322259, blah, blah, blah. Terms of sig figs, 6.02, 3 significant figures. 2.00, 3 significant figures. So that means that my answer, I can report to 3 significant figures. So we're going to keep the 3, and that first 2, it's followed by a 2, so that's going to round, or it's going to stay the same, not, I guess round down, yeah, round down. And so we would report that as 0.0332 moles of sulfur. My marker appears to be exploding on me, so that's no good. All right. Next up, we got number 10. Number 10 wants to know how many moles are present if you have 4.5 times 10 to the 25th formula units. Now, why formula units of NaHCO3? So just like atoms are the smallest component of an element, so they're the particle that comprise an element, formula units are the particles that comprise an ionic compound. So that's why the language sounds kind of awkward. It's talking about formula units, which are the particles when we're talking about an ionic compound. So it's going to be 4.5 times 10 to the 25th, so times, and it asks us to find moles. So again, we'll be finished when we find the moles value. It's 1 mole of sodium bicarbonate is 6.02 times 10 to the 23rd formula units. 4.5 times 10 to the 25th times 1 divided by 6.02 times 10 to the 23rd. And that's going to come out to be, so 4.5 divided by 6, that's 0.75. 10 to the 25th divided by 10 to the 23rd. So that would be, what? 10 to the second, 0.75. So it's going to come out to be 75 moles. Right? Let's punch it in a calculator. 4.5. Covered in liquid chalk. 4.5 to the 25th divided by 6.02. And calculator reports it 74.75. We need to round it, so since 4.5 is 2 significant figures, then we need to round that to 2 significant figures as well. So 74.75 would round up to 75 moles of sodium bicarbonate.